right, let's talk a little bit about the factor label system. If you remember, we were talking in the last video, what if I could show you a way to do a problem where you just could not find a way to mess it up? Well, that's what we're going to talk about here. We're going to talk about something called the factor label system, otherwise known as dimensional analysis sometimes. And this is a way of doing problems. And what we're going to do is we're going to apply it to converting between English and metric units, different units. But keep in mind that, I really don't care that you can go from centimeters to meters. I'm assuming you can probably do that on your own, moving decimal places in your head. What I'm more interested in is, can you go from inches to centimeters using the method? The method is what's important. All right, learn the method. Spend a little bit of time now, and it will save you a lot of heartache down the road. Because what's going to happen is we're going to apply this method to something a little bit different that's not quite as familiar to you. Those of you who've had high school chemistry probably know where I'm headed with this. And that's where it's going to pay dividends. So the reason we're doing this metric to English conversion stuff is because you need to learn the method. I promise you it will come back. So what is this factor label system stuff that we're talking about? Well, the factor label system is based on three main concepts that you already know. All right, so the first concept is if I take any number, we'll call it x, and divide it by the same thing, x not being equal to 0 for you math types out there, what do I get? Well, I get 1. 7 divided by 7 is 1. 6 divided by 6 is 1. 0.1 divided by 0.1 is 1. All right. Second concept, if I take any number and I multiply it by 1, that includes 0, what do I get? Well, I get that same number. 10 times 1 is 10, 20 times 1 is 20, so on and so on and so forth. Third concept, if I have two fractions and I'm multiplying, like 5/6 times 6/7, what can I do to simplify before I start multiplying across? Well, I got a 6 on this side down here at the bottom, and I got a 6 up here at the top. And so I can cancel my 6's, and then I can multiply across. 5 times 1 is 5, 1 times 7 is 7, and I get my answer. So I can do that if the same number is on the top and the bottom there. Well, it turns out that units cancel too. So what do I mean by that strange cryptic statement? Well, doing a problem is a lot like taking a trip. When you take a trip, you ask yourself three things. Either consciously or subconsciously. The first thing you ask yourself is, where am I? If you don't know where you are, you're going to have a really hard time getting somewhere. All right, so I'm in the science building, Fox building, 2nd floor. Okay. Second thing you ask yourself is, where do I want to go? You don't just walk out of a classroom and just start aimlessly wandering around hoping you'll end up somewhere where you might want to be. Generally you have some sort of a goal. I want to go to Taco Bell by the mall. Okay. The third thing you ask yourself is, how do I get from here to there? So I guess I'd be back in the parking lot, get on the loop, go back to loop 250 and take a left on Midkiff and then back in that way. And I find myself at Taco Bell and I can eat lunch. And so whether you're going to Taco Villa or you're going to New York or you're going to the bathroom, you consciously or subconsciously ask yourself those three questions. Well, when you do a problem, you do the exact same thing. So, for example, a standard sheet of paper is measured to be 10.0 inches long. What is the length in centimeters? All right, and I will give you 1 inch is equal to 2.54 centimeters here. Okay. Side note. 1 inch is actually equal to exactly 2.54 centimeters. That's an exact number. An inch is actually defined to be 2.54 centimeters. The metric system is so prevalent that some of your English units are actually defined in terms of the metric system. So even if you try to get away from the metric system, it comes back to get you anyway. Would I have expected you to know that 1 inch is equal to 2.54 centimeters exactly? No, I wouldn't have expected you to know that. It's not going to cause any problems here in this problem anyway. Okay, but just side note. Okay, so what do I do first? Well, the first thing I do is I say, okay, what's given to me in this problem? What do I know about this piece of paper? Well, I know it's 10.0 inches long. All right, so what I'm going to do is I'm going to write that down. I'm going to put a times sign, and I'm going to draw a line. I'm going to make a fraction here. Put one thing on top, one thing on the bottom. Pretend like you don't see this for now. Okay? And then I ask myself, okay, where do I want to go? What do I want to be in? Well, I want to be in centimeters. Okay? So I'm in inches. I want to be in centimeters. The third thing I ask myself is, how do I get from here to there? In other words, do I know anything about inches and centimeters? Well, I know that 1 inch is equal to 2.54 centimeters. Okay? These two measurements, are these equivalent? 1 inch, 2.54 centimeters. Are those the same length? Yeah, they're the same length. Okay? What do I know about equivalent quantities when I put them over each other as a fraction? Well, that's equal to 1, right? What happens when I multiply something by 1? Well, I get the same value. I don't change it. Okay? So what that means is I can multiply this 10 inches here by 1 inch over 2.54 centimeters, or 2.54 centimeters over 1 inch. Now, if I do that, I'll get a different number. But the reason I get a different number is because I'm changing units. Okay? I'm not making that paper any longer. I'm not making it any shorter. It's going to be the same length. All right, so the question now becomes, which do I want to do? Do I want to put 1 inch over 2.54 centimeters, or do I want to put 2.54 centimeters over 1 inch? Well, I want to do 2.54 centimeters over 1 inch. Why do I want to do it that way? Well, notice here I have inches here on the top. You could figure that's like divided by 1. And I've got inches here on the bottom. So what I can do is I can cancel out the inches. Now, notice I didn't touch the numbers. I'm just canceling units at this point. When I cancel out the inches, what am I left with, unit-wise? Centimeters, which is what I want. So when I do the math now, the only unit I have left is centimeters, and that's going to be the units for my answer. So basically what you do is you put on the bottom what you don't want. If this is up here on top, cancel that out, and you're left with what you need. Make sense? If you put it backwards, then your inches wouldn't cancel. You know you did it wrong. So now that we've messed with the units, now we can actually mess with the numbers. So we got 10.0 times 2.54 divided by 1 inch. Okay, I'm multiplying and dividing here. What's my rule for significant figures? Keep as many significant figures as there are in my least precise quantity, right? So how many significant figures here? Ignore that. 3. Okay, this actually is exact. If you thought it was 3, it's not going to cause any problems. This is exactly 1. Exactly 1 inch is technically actually exactly equal to 2.54 centimeters. So really the only measured value in this entire problem that has error in it is what? This. So how many significant figures here? 3. How many should my answer have? 3. So my answer is 25.4 centimeters, 3 significant figures. Make sense? Try another one? Okay, let's try another one. So, express your weight in grams. Okay, and I'll give you that 1 kilogram is equal to 2.2 pounds. So, how many grams does your chemistry professor weigh? All right, well, what do we know? Well, we know I weigh 208 pounds. So we write that down. Here, draw a factor. Okay, where are we trying to go? Well, we're trying to go to grams. Okay, do we know a direct relationship between pounds and grams? Well, no, we don't in this case. Do we know a relationship between pounds and anything? Well, I know that 1 kilogram is equal to approximately 2.2 pounds. That would be 2 significant figures here, by the way. All right. Can I use that somehow to get where I need to go? Well, I can put 1 kilogram over 2.2 pounds, or I can put 2.2 pounds over 1 kilogram. Which do you think would be more useful here? Well, 1 kilogram over 2.2 pounds. Why do I want to do it that way? Well, because my pounds cancel, see? All right. What if, ignore this here, what if we just quit right here? What if we just quit right here and did the math? What would my answer be in? would be in kilograms, because that's the unit I have left, right? But do I want it in kilograms? No, I want it in grams. So what do we do about that? Well, we draw another factor. Okay, so now I've got kilograms, and I say, okay, do I know a direct relationship between kilograms and grams? Do I know equivalent quantities? Well, I know that 1 kilogram is equal to 1,000 grams. And I know this because kilo means 1,000, right? So 1 kilogram is equal to 1,000 grams. Do I want to put the kilograms on top or bottom? Well, I want to put it on bottom because I want the kilograms to cancel. See, with the one on top over here. When I cancel that out, what's the only unit I have left? Grams. What am I looking for? Grams. So as they say in art, part of art is knowing when to stop. How do I know when to stop making factors? Well, you stop making factors when your units are exactly what you're looking for. All right, so we're in grams, and that's what we want. So notice again, we only cancel the units. We didn't touch the numbers. Now we're ready to do the numbers. So we got 208 times 1, which I think is 208, times 1,000, which is probably 208,000. And then divide that by 2.2, and then divide that by 1 if you want to. And what you'll get is you'll get 94,545 grams. All right, but do we really know my mass to the nearest gram, given the data that we have? Well, let's take a look. Again, multiplying and dividing. So how many significant figures do I have here on the 208? Well, I have 3. This is exactly 1 kilogram. That is approximately 2.2 pounds, because these metric to English units don't line up perfectly here. So how many significant figures here? 2. 1 kilogram is equal to exactly 1,000 grams by definition, so there's no error here. These are exact, that's exact. There's only 2 numbers here with error in them, the 208 and the 2.2. How many significant figures should I have in my final answer? 2. The same as the least number of significant figures here, this 2.2. That's my limiting factor there for accuracy. Okay, so I don't report this as 94,545 grams. I'll go 2 places here, and then I'll look at the next number. It's a 5, so we're going to round up, and so it's 95,000 grams. Really, you only know my weight to the nearest 1,000 grams because of this conversion that we gave you right here. Make sense? Now, 95,000 grams. How many significant figures are there? Well, again, could be 2, could be 3, could be 4. This is one of those things where it's, zeros after non-zero digits before the decimal. So a better way to report this, to say, hey, I mean 95,000 to 2 significant figures, is to put that in scientific notation. So we're going to go 1, 2, 3, 4 places back here to right past the first non-zero digit here. And so that's going to be 9.5 times 10 to the 4th, greater than 1, so positive exponent. So a better way to express that would be 9.5 times 10 to the 4th grams. And that way, you're saying the same thing, but you're saying it to 2 significant figures. Does that make sense? I would probably take either. I would probably give you the benefit of the doubt and figure, well, you probably meant 2 significant figures here. But probably a better way to report it would probably be this way if you could. All right. A paper clip weighs approximately 1 gram or so. So if you put me over here and then 95,000 paper clips over here on a balance, then yeah, we'd actually be roughly the same. Sounds like I need to lose some weight. Can you do it? All right. You want to see a harder one? You want to see a really hard one? All right, let's do a really hard one just for fun. Now, get this over here. There we go. Now, this one is probably harder than I would really put on a test, to be honest. But see, where the factor label system really shines is when the problems get hard. When they're easy problems, you can just move decimals, or you can do them in your head, and it's not so hard. But when the problems become more complicated, That's where this really helps. All right, but of course I'm not going to show you the hardest problem I can find first, because that, you got to crawl before you can walk, right? So here's one that I probably would not put on a test. Could I put something in between this one and these up here? Yeah, I think that's probably fair game. But I just want you to see how this kind of works. So here we go. The minimum speed an object must travel to escape Earth's gravitational pull, this is something called the escape velocity, is 11,186 meters per second. So if you were going to jump off the Earth, you would have to jump up with a speed of 11,186 meters per second and maintain that speed. And if you did, you could jump to the moon. Okay, but you got to jump that fast. All right, what is that speed in miles per hour? And I will give you 1 inch is equal to 2.54 centimeters. Okay, looking at this problem, is this something you think you could do in your head? Probably not. All right, so notice we got two problems here. What am I in? What am I given? Well, I'm given 11,186 meters per second. What am I trying to get to? Well, I'm trying to get to miles per hour. All right, notice I have two units here. I've got a distance unit, I got a time unit here. The nifty thing about this factor label system stuff is I can either fix the distance unit first and then work on the time, or I could work on the time unit first and then fix the distance. It doesn't matter. I'll still get the same answer. So just for fun, let's work with the distance unit first and then we'll work with the time. Okay, so what do I know? Well, I know I've got 11,186 meters per second. All right, so does it make sense to you that if something was traveling at 11,186 meters per second, where is it going to be a second later? Well, it's going to be 11,186 meters. If you're driving down the road at 60 miles per hour, where are you going to be an hour from now? Well, you're going to be 60 miles down the road, right? So I can write that as 11,186 meters for every 1 second. And I can draw a factor. Okay? Do I know a direct relationship between meters per second and miles per hour? No, not even close. All right, so this one might take a little bit. So what we can do here is we can work with the distance unit first and then the time, or we could have done the time and the distance, it doesn't matter. But for purposes of this problem, we'll start with the distance first. So in meters, I need to be where? I need to be in miles. Okay, do I know a relationship between meters and miles? No, I don't know that. Do I know a relationship between anything English and anything metric? Well, I know that 1 inch is equal to 2.54 centimeters. Okay. Does it make sense to you that if I can somehow get from meters to centimeters, then what I can do is I can go from centimeters to inches, and then if I can get to inches, I can maybe go to miles. So in other words, this is going to be my bridge to get from the English system to the metric system. If I've got a river here, and I'm standing over here and I want to go over here, I can't go straight across the river. I got to go down and find a bridge, go across the bridge, and then I can walk back, right? Well, it's kind of the same thing. Here, this is my bridge. Okay, so do I know a direct relationship between meters and centimeters? Okay, well, centi means what? 1/100th of a meter. So if a centimeter is 1/100th of a meter, how many centimeters are there in a meter? Well, there are 100. All right, so therefore 1 meter is equal to 100 centimeters. I can use that as a factor. So what do I put on top and what do I put on the bottom? Do I put 100 centimeters on top and 1 meter on the bottom? Or do I put 1 meter on top and 100 centimeters on the bottom? Well, I want to put 100 centimeters on the top and 1 meter on the bottom. Why do I want to do that? Because I want my meters to cancel and I want to be left with the centimeters. See? Get rid of what you need to get rid of and then go where you need to go. All right? Now, if I quit right here, if I just stopped, what would my answer be in? Well, it would be in centimeters per second, because those are the units I have left. Do I want centimeters per second? No, I want miles per hour. Okay, so we're in centimeters. Can I get directly from centimeters to miles? No. Can I go from centimeters to anything English here? Well, I know that 1 inch is equal to 2.54 centimeters. So maybe I can use that as a factor. So what goes on top, what goes on bottom? Well, with the centimeters on the bottom here, see, because I want that to cancel with this centimeters, I want the 1 inch on top. So therefore, 1 inch over 2.54 centimeters. All right, are we done? No, we need to be in miles. So we're going to draw another factor. So we just keep drawing factors until we get where we need to be. Is there any way I can go from inches to miles? Well, no, I don't know that. Can I go from inches to anything that might help me out here? Well, I know there's 12 inches in a foot. So how could I use that as a factor? What goes on top, what goes on bottom? Well, I want the inches on the bottom because I want them to cancel out with these inches here on the top. So 1 foot is equal to 12 inches. What if I quit right here? What would my answer be in? Well, it would be in feet per second, because those are the only 2 units I have left at this point. Okay, but we're not looking for feet per second, so we draw another factor. Okay, do I know a relationship between feet and miles? Actually, I do. I know that 1 mile is equal to 5,280 feet. So what goes on top, what goes on bottom? Well, I want the feet on the bottom, because I want that to cancel these feet to cancel those feet. Make sense? All right. Now, if I do that, now I've got miles, and that's where we're headed. We're headed to miles per hour. So I know I'm making some progress here. So my distance unit is correct. But if I quit right now, my units would be miles per second. All right. So I got to draw another factor. So we just keep going. All right. So now I want to try to get the seconds right. I'm in seconds. I need to get to hours. Do I know a direct relationship between seconds and hours? Yes, you could probably sit there and figure it out in your head, but it might be easier just to go to minutes, right? So what's the relationship between seconds and minutes? Well, for every 1 minute, there are 60 seconds. There are 60 seconds in 1 minute. 2 equivalent quantities. What goes on top, what goes on bottom? The minutes go on the bottom. Because why? Because that puts the seconds on top. Why do I want the seconds on top? Well, because the seconds over here on the bottom. See, I'm going to be able to cancel out the seconds. Do 2 things have to be right next to each other to cancel? No, for 2 things to cancel, 1 just has to be on the top and 1 has to be on the bottom. And the reason why is because multiplication is commutative. 3 times 5 times 7 is the same thing as 7 times 5 times 3 or 5 times 7 times 3. When you multiply numbers, it doesn't matter what order you multiply them in as long as you do it. So this factor here is separated from that factor, but really you could have just moved it back over here. So see, it doesn't matter if they're right next to each other. As long as 1 is on the top and 1 is on the bottom, you're good. All right? So seconds cancel. Got rid of that seconds. So what are we left with? We got miles per minute, but we want miles per hour. So do I know a direct relationship between minutes and hours? Yes, I do. I know there are 60 minutes in an hour. So 1 hour is equal to 60 minutes. 60 minutes is equal to 1 hour. So what goes on top, what goes on bottom? Well, your minutes go on top, because you want them to cancel with this minutes down here. What am I left with? I'm left with hours. Okay? So what are the only units I have left here on the top? Well, miles. What are the only units I have left here on the bottom? Well, hours. Miles per hour. Isn't that what I'm looking for? It sure is. So now I can quit drawing factors. And now it's time to do some math. So there's two ways you can do this. Either way will work. You can say 11,000 times 11,186 times 100 times 1 times 1 times 1 times 60 times 60. Write that down. And then say 2.54 times 12 times 5,280 times 1 times 1. Write that down and then divide. You can do it that way. But remember, multiplication and division are commutative. So what you can do is you can do it this way. You can say 11,186 times 100 times 60 times 60. And then take that answer, divide it by 2.54. Take that answer, divide it by 12. And then take that answer and divide it by 5,280. If you do that, you will get the exact same answer. The nifty thing is you don't have to write down a bunch of intermediate results. You just put it in your calculator and it all goes in at once, which is kind of nice. So multiply across the top and then start dividing by the numbers on the bottom, and it will work. And it's because multiplication and division are commutative. It doesn't matter what order you do them as long as you do them. But you don't have to write down intermediate results and all sorts of stuff like that and repunch things in the calculator. A lot quicker. Okay? How many significant figures do I have involved here? Well, exactly 1 second here. 1 meter is equal to exactly 100 centimeters. By the way, side note, what if I had said that 1 centimeter is equal to 0.01 meters, 1/100th of a meter? Would this work? Yes, it still works, because these two things are equivalent quantities. What if I had said 2.5 meters is equal to 250 centimeters? Would it work? Yeah, as long as these two things are equivalent quantities here. See, you're basically multiplying by 1 times 1 times 1 times 1 times 1 times 1. And so therefore, you're not changing the value. You're getting a different number, but that's because you're changing units. And that's the reason this whole thing works. So yeah, as long as these are equivalent quantities, that'd be fine. You could put 3 meters as 300 centimeters, but you know why? Why do you want to make yourself, your life any more difficult than it is? Just 1 meter, 100 centimeters. But you know, again, 0.01 meters, 1 centimeter, perfectly fine. Okay, I could see you doing that. That's okay. All right. So anyway, no significant figures here because that's exact. Those are exact because that's by definition. We found out this was actually exact, so technically that's exact there as well. I'll try not to do that to you though on the test. 1 foot is equal to exactly 12 inches. 1 mile is equal to exactly 5,280. 60 seconds is exactly a minute. 60 minutes is exactly an hour. And so really there's only one measured value with error in it in this entire problem, and that's this 11,186. So how many significant figures do I have here? 5. So how many significant figures should I have in my answer? 5. All right, so I do the math, and I come up with 25,022 miles per hour, 5 significant figures. And that's how fast you have to go to get off the Earth and get into space. This is what those rockets have to do. They've got to achieve, and that's called escape velocity, actually. All right? Now, could you do this in your head? What would you have to do this in your head? Well, you have to multiply by 100, you have to divide by 2.54, you have to divide by 12, you have to divide by 5,280, multiply by 60, multiply by 60 to do this in your head. What if, hypothetically, you did everything correct, but maybe you multiplied by 12 instead of divided by 12? Whole thing's wrong. See, all you got to do is make one mistake in your head, the whole thing is wrong. Did you make a mistake here? Well, let's check our work. Meters cancel, centimeters cancel, inches cancel, feet cancel, seconds cancel, minutes cancel. I'm left with miles, I'm left with hours, that's miles per hour. You know, these factors are right. You know, 1 meter, 100 centimeters, 1 inch, 2.54, 1 foot's 12 inches. Don't do like 12 feet and 1 inch or anything. 1 mile, 5, yep, there you go. I mean, really, the only way you could mess this up is put it in your calculator wrong. But, you know, geez, I can't do everything for you. You got to do some of it on your own. You can walk out of that room knowing you did it right because everything canceled that was supposed to cancel and all your factors look correct. It's that simple. So you can see that the longer the problem, the more the factor label system helps you. All right. Learn the factor label system. All right. Well, I guess that's chapter 1. There you go. See, you're through your first chapter already. So I guess the next video will be chapter 2. We'll start chapter 2, so make sure you got those notes. And I guess we'll see you then. So until then, I guess, bye.